Have you ever drizzled golden honey over your morning toast, or stirred it into your tea and wondered how exactly this sweet, sticky substance comes to be? You know it comes from bees, but what's really happening inside that hive? Is it simply bee spit, some kind of processed nectar? Or does the creation process involve something far more intricate and fascinating? The truth is that honey production represents one of nature's most remarkable collaborative achievements, involving thousands of bees performing specialized tasks, complex enzymatic transformations, and an evaporation process so precise it would impress any food scientist. It's far from being just sweetened flower juice. It embodies incredible biological engineering, strategic resource management, and a preservation technique that allows honey to remain edible for thousands of years. We're going to reveal the complete process right here on Stories Behind Everything. The journey of honey begins not in the hive, but out in fields and gardens, where worker bees, all of which are female, search for flowering plants. These forager bees collect nectar, a sweet liquid produced by flowers to attract pollinators. Using their long, tube-like tongues called proboscises, bees extract nectar from flowers and store it in a special organ called the honey stomach or crop. This isn't their digestive stomach. It's a separate storage compartment specifically designed for carrying nectar back to the hive. A single forager bee might visit hundreds of flowers during one collection trip, gradually filling her honey stomach with up to 40 milligrams of nectar, which represents nearly half her body weight. The type of flowers visited determines the honey's eventual flavor, color, and characteristics, which is why you can find such variety in honey types like clover, wildflower, orange blossom, or buckwheat honey. Once a forager returns to the hive, she doesn't simply deposit the nectar and leave. Instead, she transfers it mouth to mouth to a house bee, a younger worker who remains inside the hive. This transfer isn't just physical. During the exchange, the house bee begins adding enzymes from her own glands to the nectar. The most important of these enzymes is invertase, which starts breaking down the complex sugars in nectar, primarily sucrose, into simpler sugars like glucose and fructose. This enzymatic process is crucial because it makes the honey easier to digest and less prone to crystallization. Another enzyme called glucose oxidase gets added, which eventually produces hydrogen peroxide, giving honey its natural antibacterial properties. This is why honey can fight infection when applied to wounds and why it never spoils under proper conditions. After receiving the enzyme-enriched nectar, house bees don't immediately seal it away. The nectar at this stage still contains about 70% water, far too much moisture to be stable honey. If left at this concentration, the nectar would ferment and spoil, so the bees engage in a remarkable dehydration process. House bees spread thin layers of nectar across the honeycomb cells and then fan their wings vigorously to create airflow throughout the hive. This collective fanning, performed by hundreds of bees simultaneously, creates a sophisticated ventilation system that evaporates excess water from the nectar. The bees maintain the hive temperature at around 95 degrees Fahrenheit, which accelerates evaporation. They also repeatedly consume and regurgitate the nectar, spreading it across their mouths to increase surface area and exposure to air, further reducing moisture content. This process continues for days until the water content drops to approximately 17 to 18%, at which point the substance has transformed from nectar into actual honey. Once the honey reaches the proper consistency and moisture level, worker bees seal the honeycomb cell with a wax cap they produce from special glands on their abdomens. This beeswax capping creates an airtight seal that preserves the honey indefinitely. The wax itself is another marvel. Bees must consume about 8 pounds of honey to produce a single pound of beeswax, making it an expensive biological investment. The hexagonal shape of honeycomb cells isn't random either. It's the most efficient geometric shape for maximizing storage space while minimizing the amount of wax needed for construction. Scientists have confirmed that this hexagonal pattern is mathematically optimal, something bees discovered through evolutionary trial and error millions of years before humans developed geometry. The composition of finished honey is quite remarkable. It typically contains about 38% fructose, 31% glucose, 17% water, and small amounts of other sugars, along with trace amounts of vitamins, minerals, amino acids, and antioxidants. The exact ratio varies depending on the flower sources, but the low water content and high sugar concentration create an environment where bacteria and microorganisms cannot survive. Additionally, honey is naturally acidic, with a pH between 3.4 and 6.1, which further inhibits microbial growth. This combination of properties explains why archaeologists have discovered perfectly edible honey in ancient Egyptian tombs that are thousands of years old. Properly sealed, honey essentially never expires. Beekeepers harvest honey by removing frames of capped honeycomb from hives, but they never take all of it. Responsible beekeeping requires leaving enough honey for the colony to survive, especially during winter months when flowers aren't blooming and bees cannot forage. In cold climates, a healthy colony might need 60 pounds or more of stored honey to survive until spring. Beekeepers extract honey by first removing the wax cappings with a heated knife or uncapping fork, then placing the frames in a centrifuge that spins them rapidly. The centrifugal force pulls honey out of the cells without destroying the valuable wax comb, which can be returned to the hive for bees to refill. The extracted honey is then filtered to remove any remaining wax particles or debris before being bottled. Raw honey undergoes minimal processing and retains all its natural enzymes, pollen, and beneficial compounds, while commercial honey is often heated and ultra-filtered to prevent crystallization and create a uniform appearance, though this process removes many of honey's nutritional benefits. Different varieties of honey offer distinct flavors and properties based on their floral sources. Clover honey, one of the most common types, has a mild sweet flavor and light color. Manuka honey from New Zealand, produced from the Manuka bush, contains additional antibacterial compounds and commands premium prices for its medicinal properties. Buckwheat honey is dark, robust, and rich in antioxidants. Orange blossom honey carries subtle citrus notes, while lavender honey has floral undertones. Some specialized honeys, like Tupelo honey from the southeastern United States, resist crystallization better than others due to their higher fructose to glucose ratios. Honeydew honey, interestingly, isn't made from flower nectar at all, but from sweet secretions produced by aphids and other insects feeding on trees, giving it a completely different flavor profile that's less sweet and more complex. Honey's health benefits extend beyond being a natural sweetener. It contains antioxidants that may help reduce the risk of heart disease and certain cancers. Its antibacterial properties make it effective for treating burns, wounds, and coughs. In fact, some studies suggest honey is as effective as certain cough medicines for suppressing coughs in children. However, honey should never be given to infants under 1 year old because it can contain botulism spores that immature digestive systems cannot handle safely. For adults and older children, though, honey provides quick energy, soothes sore throats, and may even help with seasonal allergies when local honey containing regional pollen is consumed regularly. Despite its benefits, honey is still a sugar and should be consumed in moderation as part of a balanced diet. The honey industry faces significant challenges today, primarily due to colony collapse disorder and declining bee populations worldwide. Factors including pesticides, habitat loss, climate change, parasites like varroa mites, and diseases threaten bee colonies globally. Since bees pollinate approximately 1/3 of the food crops humans consume, their decline poses serious risks to agriculture and food security. Supporting sustainable beekeeping practices, buying honey from local beekeepers who prioritize colony health, and creating bee-friendly gardens with diverse flowering plants can help support these essential pollinators. So the next time you enjoy honey's golden sweetness, remember the extraordinary process behind it. Thousands of bees made countless flower visits, performed enzymatic alchemy, engaged in collective dehydration efforts, and constructed intricate wax storage systems, all to create that spoonful of liquid gold. What appears simple is actually one of nature's most sophisticated food production systems, refined over millions of years of evolution and still unmatched by human technology. Thank you for watching. If you have ideas for our next video, please share them in the comments section below. We'll make sure to acknowledge your contribution. Thank you for joining us on this journey through stories behind everything. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.